this question, this and this. Do these two questions, and then we'll go to Ohm's law. Rudra, is the question clearly visible on the screen?
Yeah.
This question. What formula you are going to use? V is equal to W by Q. Okay, this is the formula. Work done to bring the charge from one point to another in an electric field. You can tell me just verbally. You need not to do the question. Fast, 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 fast. Sophia, fast. Done, 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 done.
Ma'am, could you please wait?
Yes. Come again, Sophia. What you said? Okay. Here you also have to apply this formula. Q is equal to IT. In place of Q, you have to put IT. And then you can solve for I, because T is also given. Done. Rudra, done.
No, ma'am.
Just do it quickly. Just put it in the formula, no? You need not to do anything.
Yes, ma'am. So correct.
Everything is given.
Ma'am is 8.
Hmm?
I'm 8.
8 ampere.
Yes.
8 ampere. Okay. What about you, Sophia?
And that's for the sixth question.
Hmm?
That I got for the sixth question.
That you got for the sixth question. This is how much charge you have to find charge in this question.
Oh.
You got 8 as what?
I thought they were asking for potential difference.
No, I'm asking that what you have got for 3. Question number 3.
Ma'am, I haven't done that yet. I was doing this.
Yes.
I haven't done that yet. I was doing the sixth.
Okay. And what you have got?
8 ampere. That's
8, not ampere. It must be coulomb. If you have found out the charge. Do the question number 3. And Sophia has got 5 by 3. Okay, let's see what the answer will come. I is equal to W by V, and then one more quantity, that is T. Okay, so W is 100, and V is given as 12, and T is given as 5. Fine. Dividing it by this, and then you'll get 5. If you'll 4 and if you'll divide it by 4, so 4, 5 and 3. So 5 by 3. Yes, Satya, you're correct. Current will be 5 by 3. Rudra, solve question number 3, and Safia, solve question number 6. And you got 8 for this now. Let me see. V is equal to W by Q. So 220 is equal to 176 by Q. So you got 5 by 3? Okay.
yes.
Q is equal to 1760 by 220. 0 got cancelled, and then 8 times. Yes, correct. 8 coulomb. Correct. Sophia, you got 8 coulomb? Sophia, we got 8 coulomb? Yes. Okay, fine. So electric potential is a scalar quantity, vector quantity, neither scalar nor vector, sometimes scalar, sometimes vector. Tell me. What is it? Electric potential is what? Electric potential is what? Scalar quantity. Tell me fast. Electric potential is a scalar quantity. क्या इसमें प्लस माइनस का कोई सवाल होता है क्या? डायरेक्शन नॉर्थ वेस्ट ईस्ट का कोई भी होता है? नहीं है ना? तो फिर ये कौन सी होगी? Scalar quantity. Okay, it's scalar. Yes. Which among the following provides the potential for the steady flow of current inside the copper wire? क्या चीज provide करता है potential for the steady flow of current? Battery. Exactly. Battery. Exactly. What is the SI unit of electric potential difference? Rudra, what is the SI unit of electric potential difference? Fast. SI unit of electric potential difference. Joule second, joule coulomb, joule per coulomb, joule and ampere or ampere. Rudra, tell me.
1 second. I don't remember.
Fast. You just use formula for this. It should not take any time.
It's joule by C.
Joule per coulomb. Okay, joule per coulomb. And also it is called volt. Okay, we denote it by volt. V, capital V. Fine. Okay, now we'll come to our point. Now, one thing that I forgot to tell you in the last session, last session, that what is the device that is used to measure current in the circuit? That how much current is flowing in the circuit? How can we know? There must be some device that will measure the amount of current that is flowing inside the circuit, right? So what is that device name? Anyone? What is the name of that device that is used to measure the current in the circuit? That is ammeter. Ammeter name itself is representing that it is ampere. Ampere ka meter means the unit for current is what? Unit for current is ampere, right? So AM ka meter मीटर लगता है ना घर पे ना, मीटर लगता है, जो चीज नापने के लिए कहा जाता है ना कि मीटर है, इसका मीटर है, ये वो मीटर है, तो ये क्या हो गया, एमीटर, मींस एम्पियर नापने वाला मीटर। ओके, नेम itself is representing that what it will measure. Ammeter will measure what? It will measure current in the circuit. Fine. Ampere meter. It will measure current in the circuit. Now, the device that is used to measure voltage in the circuit. Voltage in the circuit. What it is? What it is? Safia, tell me, which device is used to measure voltage in the circuit? Do you know? Voltmeter? No, no, it's voltmeter. Yes, yes, you must have. Yes, yes, fine. Voltmeter. Voltmeter also is representing itself showing that it is the meter for volt. It is the device to measure volt. Volt means voltage. Okay, and one more device is there, galvanometer. What is the work of that? Galvanometer, that is not we have to study right now. So galvanometer, what is this device is used for what? Can anyone tell? Can anyone tell? Rudra, can you tell why what the galvanometer does in the circuit? If we join it with, means if we place in the circuit, what it will do? Galvanometer, what is the work of this? It will not measure the
It,
amount of,
it detects the flow of current.
it detects the flow of current. Correct. It detects the flow of current. Whether the current is flowing in the circuit or not, it detects the flow of current. So it's called moving coil galvanometer. It detects, it means there is a needle that will detect that if it will go like this, it will go like this. If it will show the deflection, then then we will see that yes, galvanometer is, sorry, the current is flowing in the circuit. Okay, it detects the flow of current and in which direction the current is flowing. Fine. So, and one more thing was there. That voltage, that see, always means there is a, the flow of current is always from higher potential to lower potential, right? This is the battery, this is the bulb. Okay, and what else is there? ओके फाइन, यहाँ पर इसको हम लगा देंगे बैटरी स्विच. As we switch on means switch on or close the key. As we close the key, what will happen? The current will start flowing from higher potential to lower potential, right? The current always flows from higher potential to lower potential, right? Current always flows from higher potential to lower potential. Means in any of the thing, in any of the, you can also see in water tank, like we are having two water tank. This is fully filled. Okay, this is fully filled with water, and we have an opening is there to let the water flow from this tank to another tank. Okay, so what it will do here in this is the empty, this is the empty tank, this is the empty tank, and this is the filled tank. Okay, what will happen? What will happen? The filled tank, we have to do nothing, we will do nothing, but by itself water will flow from this to this, right? Or make it like this, now it will be cleared, more clear. Here is the another tank. Okay, here's the another tank, this is the empty one. So water will flow from higher potential to lower potential, right? Higher potential to lower potential means it's the tank is filled. Here the tank is filled, it will keep on going until this level, right? Until this level, because here it's the opening. Means always everything passes from higher potential to lower potential, or we say higher pressure to lower pressure, higher pressure to lower pressure. Okay, now we'll easily understand that what Ohm's law is. You yourself will tell me the Ohm's law. Okay, have you done these examples, Sophia? Have you done these examples? We already have done these examples. Okay, now see, you must have had listened about in the fourth, fifth, sixth class, fifth grade or sixth grade about the sea breeze, land breeze. Have you ever studied about sea breeze, land breeze? पढ़े होगे ना sea breeze, land breeze? कैसे एयर फ्लो करती है? हेयर हेयर यहाँ पर मान लो यहाँ पे ठंडा रीजन है, ठीक है, यहाँ पे गर्म रीजन है, ये गर्म रीजन है, एंड दिस इज द cool air. Here the cool air is there, and here the hot air is there. Hot air rises up, right? Hot air rises up, it rises up and creates a vacuum type of air thing, vacuum type, or means there is no, because here it will be less air, right? Because the hot air will go up, go up, right? It will rise. So here in the region, in the lower region, what the vacuum type of thing will create it. And from the region of here the cold air will be there. तो cold air तो पूरी जगह में रहेगी, ये तो uprise नहीं करती, right? तो क्या होगा कि the region, the suppose कि यहाँ पे cold air है, तो क्या होगा, what will happen, the cold air will shift to this side. Yes, now cold air will shift to the region of where the hot air has rised up, right? Hot air ऊपर जा चुकी है, cold air कहाँ होगी, इधर साइड आएगी. Means here the low pressure has got created, and here the high pressure is there. Here high pressure is there of air, right? Here low pressure of air is there, and here high pressure of air is there. So to maintain the pressure, what will happen, the air from the high pressure will go to the lower pressure side, right? It will go to the lower pressure side. So what's happening if suppose if here it's here it's 50 Pascal. 50 Pascal, the unit of pressure is Pascal, right? So here is 50 Pascal, here it is 100 Pascal. Okay, pressure is there. Here it's 0 Pascal, and here it's 100 Pascal. So in which region, in which case, suppose this is the first case, case 1, and suppose this is the second case, case 2. In which region, in which case the air will move faster? In which case the air will move faster? In first case or in the second case? Safia, किस केस में air बहुत जल्दी से pass होगी? Second case, right? Because here it's large, more pressure difference. Here it's the difference of 100 Pascal, and here it's the difference of 50 Pascal. So as compared to the first case, the air will move faster in the second case, from the region of higher pressure to the region of lower pressure, right? Means more the pressure will be there, more easily the current will flow. More easily the air will flow. Okay, this is what Ohm's law will tell us. Means you yourself will tell me that what the Ohm's law is. Okay, so means higher the pressure, higher the airflow. Okay, अभी तो यहाँ पे हम लोग विंड के एयर प्रेशर की बात करें. अब हम लोग क्या करेंगे, किसके प्रेशर की बात करेंगे, इलेक्ट्रिक प्रेशर की बात करेंगे. इलेक्ट्रिक प्रेशर में का मतलब क्या हुआ, वोल्टेज की बात करेंगे. ठीक है, इलेक्ट्रिक प्रेशर मींस वोल्टेज डिफरेंस. इलेक्ट्रिक प्रेशर मींस यहाँ पे अब सर्किट की बात आ गई तो इलेक्ट्रिक प्रेशर मींस voltage difference, potential difference. You can say potential difference. Okay, potential, electric pressure and potential difference. In the word of electricity, we say electric pressure as potential difference. Okay, अब बताओ, here we have two circuit. Okay, this circuit and this circuit. Here we have two circuits. Now in the first circuit you are given 12 voltage. What is electric potential? अरे बताए थे ना, electric potential difference and electric potential, Safia. The first topic of the second, the first thing of the second topic, that moving, how much work is done in moving a charge from infinity to that point, right? Electric potential हो गया. And potential difference is what? Moving of charge, how much work is done in moving a charge from one point to another in an electric circuit. Don't get confused between electric potential and electric pressure. भूल जाओ, इलेक्ट्रिक प्रेशर भूल जाओ. ठीक है, अभी यहाँ पर हम लोग प्रेशर यहाँ पे बात की है ना, बस सेम थिंग है. यहाँ पे हम लोग करंट का प्रेशर हो रहा है, यहाँ पे प्रेशर हो रहा है, तो हम लोग उसको पोटेंशियल कह दे रहे हैं. यहाँ पे तुम प्रेशर, डोंट गेट कंफ्यूज्ड. ओके, यहाँ पे हम लोग अभी प्रेशर की बात किए थे ना, इसके बारे में भूल जाओ. ठीक है, बस इतना याद रखो, ज्यादा प्रेशर हो रहा था, ज्यादा प्रेशर डिफरेंस हो रहा था, तो ज्यादा एयर फ्लो कर रही थी, राइट? तेज से एयर. फाइन, इतना याद करो. अब we have two circuits. We have two circuits. With one with the 12-volt battery and another with the 9 volt. Means इसका potential difference है 12 volt. Okay, from this. This is the battery, right? ये 12 volt का है and the second case it's of 9 volt. 9. Okay, ये 12 volt का है, ये 9 volt. अब किसमें करंट ज्यादा अच्छे से फ्लो होगा? किसमें करंट ज्यादा अच्छे से फ्लो होगा? In which circuit the current will flow, the more current will flow? What do you think? एयर भी तो करंट ही है ना, एक तरीके से कह सकते हैं. यहाँ पे प्रेशर ज्यादा था तो क्या हो रहा था? करंट इस केस में ज्यादा ज्यादा बह रहा था, मींस एयर करंट ज्यादा बह रहा था. यहाँ पर करंट, एक्चुअल करंट जो करंट लगने वाली होती है चार्जेस की वजह से, तो यहाँ पर किस केस में, in the first case or in the second case, in which case the current will, more current will flow? First case. Why? Because higher potential difference is there, right? Potential difference ज्यादा है तो ज्यादा करंट फ्लो कर जाएगी, right? Potential difference ज्यादा कम ही है तो उसको ज्यादा, मींस लाइक अगर किसी बच्चे के पास ज्यादा कम नॉलेज है, नहीं ये वाली चीज नहीं. ओके फाइन. तो अगर ज्यादा पोटेंशियल डिफरेंस है तो क्या होगा? ज्यादा करंट बह जाएगी. जैसे कि यहाँ पर ज्यादा प्रेशर डिफरेंस था तो करंट, तो एयर करंट ज्यादा बह रही, ज्यादा तेजी से बह रही. इन दिस केस V ज्यादा था, V ज्यादा हो रहा है तो करंट भी ज्यादा हो रहा है ना, राइट? V ज्यादा हो रहा है तो करंट भी ज्यादा. रुद्र अंडरस्टूड ना? समझ रहे हो ना? अंडरस्टैंडिंग?
Yes, ma'am.
If we are increasing the voltage, then current is also getting increased. It means that what you will say कि V is directly proportional to I or V is inversely proportional. What you will say? V is directly proportional to I or V is inversely proportional to? Directly proportional. तो तुम ही तो बता दी what the Ohm's law is. This is the Ohm's law. यही तो हमको बात करना है, right? यही तो बात होनी है. V is directly proportional to I, right? The current flowing in the circuit is directly proportional to the potential difference in the circuit. Okay? अब देखो, ये यहाँ पर हम लोग एक बात पढ़ लेते हैं ओम्स लॉ. यहाँ पे क्या लिख रहा है? According to this law, the electric current flowing through a conductor is directly proportional to the potential difference applied across its ends, providing the physical condition remains unchanged. Physical condition मत चेंज करना. जो टेम्परेचर है, जो भी टेम्परेचर ही मेन कहला जाता है फिजिकल कंडीशन में. टेम्परेचर चेंज नहीं करना है तो क्या होगा? द इलेक्ट्रिक करंट फ्लोइंग इनसाइड द the electric current flowing through the conductor will always be directly proportional to the potential difference applied across its ends. Okay? इनके बीच पोटेंशियल डिफरेंस कितना है, उसी पे डिपेंड करता है कि करंट कितना फ्लो करेगा. मोर द पोटेंशियल डिफरेंस विल बी मोर द करंट. ओके. तो अब देखो, अब हम लोग को ये चीज नहीं पसंद होता है, ये प्रोपोर्शनैलिटी साइन को हम लोग नहीं पसंद करते, क्योंकि हम लोग फॉर्मूला नहीं बना पाएंगे तो क्वेश्चन सॉल्व नहीं कर पाएंगे. तो इस प्रोपोर्शनैलिटी साइन को हमें भगाना पड़ता है, बहुत भयंकर तरीके से भगाना पड़ता है. अब हम लोग क्या करें? मान लेते हैं इस प्रोपोर्शनैलिटी साइन को हटा दे, V इज इक्वल टू I तो रहेगा ही. मान लेते हैं अब इस प्रोपोर्शनैलिटी साइन को हटाए हैं, इक्वल टू लिखे हैं, तो हमें कुछ तो ऐसा करना पड़ेगा, यहाँ पर लिखना पड़ेगा, जिसकी वजह से क्या होगा, जिस पर कि I हमारा और कुछ पे डिपेंड होगा. बिकॉज इफ वी remove the proportionality sign and add this equal to sign, then it's always followed by some proportionality constant, right? We have to write some proportionality constant. Let it be x. Okay? अभी हमें नहीं पता ये क्या है, ठीक है? Let it be x. अब क्या करना है? V is equal to IXI. अब यहाँ पे देखो, if we see this, कि I will be equal to, if we rearrange this equation, okay, if we rearrange this equation, then what we'll get? V upon x. Will we get this? V upon x. Will we get this? Right? It means that this is a quantity which is varying inversely with the current, right? This is the quantity, this x is a quantity which is varying inversely with the current, right? It is varying inversely with the current, means it is uh, stopping the current to flow in the circuit. It's providing hindrance to let the current flow in the circuit. Yes or no? Current is flowing in the circuit, but it's providing current wants to flow in the circuit, wants to flow in the circuit, but something is there, something x is there, which is applying some resistance to resist the flow of current. This is what we called it as resistance. This is what we called it as resistance. This is what x is. Here x is working as a resistance to the flow of current, because it's doing what? It's stopping current to flow inside the circuit, right? It's stopping current to flow inside the circuit. ये रोक रहा है, लेकिन करंट बहना चाह रहा है, फिर ये रोक रहा है, कह रहा है रुक जाओ, कह रहा है नहीं बहेंगे, कह रहा है रुक जाओ नहीं बहेंगे। तो रोकने वाला काम जो है वो कौन कर रहा है? ये एक्स कर रहा है। तो ये क्या कर रहा है? रेजिस्ट कर रहा है। इसका नाम क्या होना चाहिए? रेजिस्टेंस होना चाहिए। इसलिए हम लोग इस एक्स को क्या कहते हैं? आर। मतलब रेजिस्टेंस को we denoted by R. So in place of X, we write what? V is equal to, this is what the Ohm's law, the expression for the Ohm's law is. यहाँ पे तो ये तो अभी बात हो गई थी, मेन तो यही है ही, Ohm's law तो यही है, V is directly proportional to I. But we have to get rid of this proportionality sign anyhow. We have to get rid of this proportionality sign. And we have to introduce one new variable, that is X. And in place of X, we have to write it R, because it's working like resistance to, which is resisting the flow of current in the circuit. So that's why we have introduced this resistance in this relation, V and I relation. ठीक है? समझ में आया ये बात? ओम्स लॉ समझ में आया? नहीं आया? आया कि नहीं आया? सफिया बताओ, मजा आया कि नहीं आया? यस और नो? यस, ओके। तो अब यहाँ देख लो, हम लोग यहाँ पर कांस्टेंट टेम्परेचर कांस्टेंट होना चाहिए, क्योंकि टेम्परेचर बदलेगा तो थोड़ी सी दिक्कत आ सकती है। ठीक है, तो चीजें बदलती हैं, तो वो भी हम आगे पढ़ेंगे, हम लोग आगे पढ़ेंगे। ठीक है, तो V is potential difference applied across the ends of the conductor through which current I flows. Then according to Ohm's law, what happens? V is directly proportional to I at constant temperature. So in order to get rid of this proportionality sign, we introduce one newcomer, that is R, which is acting as a resistance in the circuit, and what we call V is equal to IR. Also we say I is equal to V by R. Okay, in whatever way you can write. Now we'll see the graph for VI. The graph तो बड़ा मजेदार होगा। तो ग्राफ क्या करेंगे कि, अच्छा तुम लोग वो पढ़े होगे ना, distance is equal to speed into time, right? It means speed is equal to distance upon time, right? पढ़े हैं ना हम लोग? Speed is equal to distance upon time. What अगर if it is a uniform motion, then how uniform motion, class 9 में ही तो पढ़ी हो तुम, right? If it is uniform motion, how the graph look like? How the graph will look like? If it is what? V किस में लिया जाता है? V इसमें लिया जाता है क्या? ठीक है, तो if it is uniform motion, then how the graph will look like? कैसे ग्राफ लगेगा? बताओ, जल्दी बताओ, बताओगे तो बनाएंगे। रुद्र बताओ, how the graph will look like in a uniform motion? Tell me, Rudra.
Straight line.
Straight line, like this? No, no.
No. From zero, from origin.
This will be our uniform motion. VI. Sorry, VI क्यों लिखे हैं? Sorry. Distance time का भी बना रहे हैं ना हम लोग किसका बना रहे हैं? Distance time का बना रहे हैं. This will be our time and this is the distance. Okay, this is VI graph. अब क्या होगा? If we calculate its slope, then what we will get? If we calculate its slope, then what we'll get? Slope means y by x. Y by x means this d by t. D by t means what? D by t means what? D by t is what? Speed. We'll get speed, no? Means speed will be the slope of this graph. Speed will be the slope of this graph, right? This is the slope. This is the slope, right? This is the slope. How much the slant is the equation. How the slant is the line, right? कितनी slant है line वो पता चलता है किससे slope से, right? And slope is what? The speed in distance time, right? अब हम लोग अगर बात करें if we talk about vi, यही तो है r is equal to v by I, यही तो है जो कि क्या है, जो कि क्या स्पीड इज इक्वल टू डिस्टेंस अपॉन टाइम. दिस इज व्हाट इट इज. स्पीड इज इक्वल टू डिस्टेंस अपॉन टाइम, रेजिस्टेंस इज इक्वल टू वोल्टेज अपॉन, राइट, वोल्टेज अपॉन आई. तो दिस इज इतना हिलता हुआ नहीं रहेगा. एक्चुअली ये ना पॉसिबल नहीं होता है कि हर कंडक्टर जो है इस तरीके का ग्राफ दे. ये बहुत ही रेयर केस होता है या फिर आइडियल केस होता है. यू कैन से रियल केस नहीं होता, ये आइडियल केस होता है. ओम्स लॉ, ठीक है, ये आइडियल केस है. ज्यादातर डिवाइस नॉन ओमिक ही होते हैं, ज्यादातर नॉन ओमिक कंडक्टर ही होते हैं, ठीक है. तो ओमिक कंडक्टर रेयरली होते हैं. तो ये वी आई ग्राफ कैसा होगा? स्ट्रेट लाइन होगा, राइट? सेम ही तो है, सिर्फ वेरिएबल तो चेंज हुआ है, राइट? अब इसका स्लोप हमें क्या बताएगा? इसका स्लोप हमें क्या बताएगा? जल्दी बताओ. व्हाट इट स्लोप विल टेल अस? vi slope, what it will tell us? What it will tell us? Resistivity? No, don't tell resistivity. Resistance. Yes, its slope will tell us resistance, because we have to do y by x, right? Because slope is y by x. In maths you will study about slope. Okay, y ये तुम पढ़ोगे y2 minus y1 upon x2 minus x1. You all will study about this, the slope in the maths, or must have had studied. I don't think that you must have had studied. I think you will study about slope, that y2 minus y1 upon x2 minus x1. Okay, y by x, ठीक है. तो ये slope होता है, and it's also called tan theta, because tan theta तो तुम लोग पढ़े ही होगे. tan theta होता है what it is perpendicular by base, right? Perpendicular by base means y by x. Yes, p by b, perpendicular by base. Also we say it like sin theta by cos theta. तो अभी sin theta by cos theta तो यहाँ पे हमको नहीं पढ़ना है, तो मैथ्स है. तो यहाँ पर हम लोग को थोड़ा सा बस ये, वैसे भी हमको ये भी नहीं पढ़ना है अभी, बस ऐसे एक्स्ट्रा में बता रहे थे. p by b, y by x. तो what slope is, right? I want to tell you what slope is. Tan theta also we call it as slope. तो y by x, और यहाँ पे क्या हो जाएगा? ये क्या बता रहा है? y by x यहाँ पर क्या है? r है, क्योंकि y में v है और x में i है. तो दिस इज r इज इक्वल टू v बाई i. ओके, तो यहाँ पर स्लोप इज द रेजिस्टेंस इज द स्लोप ऑफ वी आई ग्राफ. तो ये हमारा ग्राफ है. लीनियर नहीं, what we say, straight line. Okay, straight line. A graph will be straight line for what? For Ohm's law. Okay, means अगर वो बढ़ेगा तो वो बढ़ेगा. भाई भाई हैं दोनों, भाई भाई. अगर वो बढ़ेगा, अगर वोल्टेज बढ़ा दो तो करंट बढ़ेगा. अगर वोल्टेज घट गया तो आई घट गया. if this will be very elated, it will be also elated. If it will be under the weather, it will also feel under the weather. Okay, fine. Okay, yes. Okay ना कि नहीं? Okay, both are brothers. Okay, तो ये देखो यहाँ पर हमारा ग्राफ आ गया. स्लोप थीटा भी कहते हैं, थीटा. ओके, तो ग्राफ बिटवीन पोटेंशियल डिफरेंस V and the corresponding current I is found to be a straight line passing through the origin for metallic conductors. metallic conductors होंगे ही, नॉन मेटालिक तो होंगे नहीं. नॉन मेटल तो करंट फ्लो करता नहीं है, ठीक है. तो पोटेंशियल डिफरेंस आ गया, करंट आ गया, स्लोप बन गया. तो क्या हो गया? R बन गया. R इज इक्वल टू V बाई I हो गया, ठीक है. तो अब देखो यहाँ पर भी दिया हुआ है tan थीटा, ये भी दिया है, ठीक है. V बाई I रेजिस्टेंस. ओके, एवरीथिंग इज गिवन. रेजिस्टेंस, अब देखो रेजिस्टेंस और रेजिस्टिविटी में फर्क होता है, वो हम लोग नेक्स्ट क्लास में पढ़ेंगे, ठीक है. रेजिस्टेंस और रेजिस्टिविटी में पढ़े, इसलिए वो मत करना कि रेजिस्टेंस को रेजिस्टिविटी भी कह सकते हैं. नो. रेजिस्टेंस दूसरा है, रेजिस्टिविटी दूसरा है. रेजिस्टिविटी इज द प्रॉपर्टी ऑफ अ मटेरियल. ये रेजिस्टिविटी फिक्स होती है किसी मटेरियल के लिए. कॉपर की रेजिस्टिविटी विल बी फिक्स एवरीवेयर, अब चाहे तुम मून में लेके चले जाओ, ठीक है. एंड बट रेजिस्टेंस, we can change the resistance of the circuit, but resistivity of the material cannot be changed. Okay, resistivity is the property of a material. Fine. कॉपर की अलग होगी, गोल्ड की अलग होगी, जिसकी जितनी रेजिस्टिविटी होगी वो उतना कम करंट फ्लो करा पाएगा। ठीक है, इस तरीके का होता है। फाइन, ठीक है। तो करंट ऑफ अ कंडक्टर इज गिवन बाय दिस, सॉरी रेजिस्टेंस ऑफ अ कंडक्टर इज गिवन बाय दिस। और हाँ, 1 ओम, अब वो तो वैसे ही बात हो गई। 1 एम्पियर करंट क्या होता है, तो 1 वोल्ट क्या होता है, तो बस क्या कर दो, हर चीज को 1 बना दो। 1 सॉरी 1 ओम विल बी इक्वल टू, सबसे पहले तो ये लिख दो, R इज इक्वल टू V बाई I। उसके बाद फॉर्मूला लिख दो, सॉरी क्या लिख दो, सबके यूनिट्स लिख दो, ओम V बाई A। फाइन, ये लिख दो। अब सब में 1 1 1 लगा दो, 1 1 1, बस यही है तुम्हारा काम, बन गया। 1 ओम, 1 ओम, what is 1 ohm of resistance? 1 ohm of resistance, it is said to be 1 ohm resistance when, if a potential difference of 1 volt, if the potential difference of 1 volt across the ends of the conductor, fine, ends of the means from potential, from positive terminal to negative terminal की बात हो, ends of the conductor makes a current of 1 ampere to flow through it। पूरा 1 एम्पियर करंट फ्लो कर रहा है। अगर 1 वोल्टेज ऑफ करंट 1 एम्पियर करंट को फ्लो करा सकता है, तो उसको हम कहेंगे कि उस वायर में 1 ओम रेजिस्टेंस है। ठीक है, 1 ओम रेजिस्टेंस है। तो बस 1 1 1 हर जगह लगा दो और फिर इसी मैथ को इंग्लिश में कन्वर्ट कर दो और फिर, ठीक है, समझ में आ गया? क्लियर क्लियर क्लियर। अब हम लोग जो है कल पढ़ेंगे, मतलब नेक्स्ट क्लास में पढ़ेंगे। देखो एक क्वेश्चन भी है, बहुत ही इजी सा है, चलो नेक्स्ट में करेंगे। ठीक है, तो अब हम लोग करेंगे कुछ कुछ क्वेश्चंस, तुम लोग लगा ही सकोगे इसके उसके असाइनमेंट के। तो ठीक है, फिर विल मीट नेक्स्ट इन द नेक्स्ट सेशन।